In this section, we'll talk about image integrity. The question I always like to ask here is, does a picture lie? You've always heard the proverb, a picture never lies, but is that true? Well, as you obviously know in modern times, this is definitely not true. Pictures lie quite often, and we kind of expect that from fashion magazines. Pretty much everybody knows that the cover images you see on a lot of the magazines on the grocery store shelves, we know that they've been majorly manipulated, and it's just kind of expected and understood. However, obviously, when you're talking about scientific data, it's another thing altogether. We expect images of data to be exactly what they are and not manipulated in any way. So we do have some techniques we can use to determine if an image has been manipulated, and we call this image forensics. It's a service we offer. We use various image editing software and some investigative techniques to determine this, and here's a perfect example. This image looks perfectly innocent. I have no idea what it is. I'm not a scientist, but don't see anything wrong with this image. It looks perfectly normal. However, by playing around with it a little bit, we discovered this, that it was very obvious when you look at all these lines here, if you are familiar with what you can do in Photoshop and whatnot, that somebody came in here with a paintbrush tool of some kind and painted out a whole big chunks of the background. Now, this could be completely innocent. I will point that out right at the start. There might not have been anything there. However, we know that it's been manipulated because of this, and we have no idea of knowing what used to be there, if it would matter to the science or if it didn't matter. So it's important to think about these things, because in this modern age of Photoshop, where everything is expected to be manipulated, it's sometimes not considered that maybe you shouldn't. So here's a perfect example. Another example is something we see actually very commonly, gels. Now, again, I don't really know what gels are all about. Some people have tried to explain it to me, but it hasn't really stuck in. But I do know this. When you see a gel image like this, this was, just by the way this is built, it looks like it should be all one gel, all made at the same time. However, by doing a little bit of adjustment on this, if you look closely, what you'll see here is you'll see kind of a hard edge going along here, and you see something extra at the top, and then it changes where you've got the hard edge at the bottom. And what this makes it very clear is that this is actually two different gels. That these blots here were taken in at one time, and these three were taken at a different time, and then they were spliced together. Again, that's not necessarily fraudulent. However, it leads you to question. There's no way of knowing from looking at the image above that this is two gels. So it's a key thing. I also wanted to show you this one, which is another situation altogether. At first look, this looks perfectly fine, but let's zoom in on this bottom one, and then what I'm going to do is I'm actually going to do a curves adjustment. And what I'll show you is something very interesting happens. Actually, this one is not the obvious one. You can see it a little bit. See how you can see a little square there? Well, let's actually undo that curves adjustment for a second. And back it back out, and I guess it was this one. You can see it a little bit even looking at it here, but when I do the curves adjustment on it, very obvious that there's a box there, and this is definitely not natural. If I zoom out, you can see how this is not part of the rest of the thing, and you can see it in this top piece too. So very obviously manipulated, and just this area was manipulated in a way that could potentially be fraudulent. Again, it might not be. It may be just to add emphasis to these three green blots, but all the same, it's hard to know for completely sure. So, excuse me. The quick answer is images should not be manipulated. Scientific images should not be manipulated really at all. They should capture the data exactly. They should show the data exactly as it was captured. And there's some guidelines for this made by the Council of Science Editors, and here's a link to it. Which basically it's a white paper on promoting integrity in scientific journal publications to make sure that everything is above the board as it's supposed to be. So it's worth reading through this. But some particularly pertinent points I'll go ahead and point out right here. This comes directly from that white paper, and it pretty much sums up our point of view too. No specific feature within an image may be enhanced, obscured, moved, removed, or introduced. Now, adjustments of brightness, contrast, and color balance are acceptable if they are applied to the whole image. In other words, as long as it's done globally, and as long as they do not obscure, eliminate, or misrepresent any information present in the original. That's kind of the key point. You don't want to misrepresent any information. And then we talk about gels specifically. The grouping of images from different parts of the same gel or from different gels, fields, or exposures must be made explicit by the arrangement of the figure. And the most obvious way to do this is dividing lines and in the text of the figure legend. So in other words, if there are two gels, rather than just splicing them together, it's important to put a divider in between so it's really clear to anybody reading it that it is two gels. And this is a general rule it's good to put in. If original data cannot be produced by an author when asked to provide it, the acceptance of the manuscript may be revoked. This is simply if there's a suspicion of inappropriate manipulation. You need to look at the original data, and that will help determine whether there has been any manipulation. At DJS, we'll point out that we are just investigators. We're not really the judge of this because we're not scientists. So the people who would actually determine whether any particular manipulation has been fraudulent or inappropriate would be determined by science editors. Well, that is all I have about image forensics. Thought I might finish with a little cartoon that I kind of liked. Understanding food labels is always a fun thing. Well, that will do it. Thank you very much for your time, and we'll spend a little bit of time on some questions.